Um, I think we waited a bit for everyone. So welcome to the session, everyone. Um, Basically, the purpose of me doing this is that I worked with Elastic since about the beginning of 2018, late 2017 actually. And at that time, we were using Elastic 6.4. Um, and I left that job about a month back, and since then I've talked to at least 5, 6 different companies, and they're all, or at least most of them, are very interested in what Elastic can do, and they're really surprised at the kind of capabilities it has. So I wanted to do this session in order to go through the thought process that I go through when I set up a stack, an Elastic stack. And Elastic has some products which are very good value for money actually. So you can set them up very quickly, very easily, and they provide very good capabilities right out of the box without having to invest a lot of time in that. So I'll be talking about those, and I will also show a bit of Logstash and a bit of Apm as well, because that is something that unless you've actually used it, it's a bit tricky to get around. So what I've done is that I have set up most of the things already, but I will also be setting them up, some of them as we go on. And this is a live setup session, so most probably there are going to be some mistakes, but basically that's what a setup is like. So I'll try to share as much as possible of my own thought process while I do these things. So basically, the question is that why should we use Elastic Stack? There are others available as well. So Elastic actually has a very powerful stack, and it's used for system observability. So observability is a newer concept in which you can actually see what is going inside your system, whether it's monitoring, whether it's structured logs, whether it's alerting, or there's something called tracing or distributed tracing. So Elastic gives capability for that. And Elastic has a basic license which does not cost any money, and you can set it up on your own machine. And those capabilities are in that basic license as well. So you don't need to spend a lot of money or any money at all to actually set it up, and you can use it on your own to monitor your own infrastructure and to monitor your own applications. Elastic is also used for geospatial analysis, so it has very good capabilities for doing maps. And you can also analyze the performance of your applications. So it has something called distributed tracing, in which you can enable and you can see what is happening inside your application, a Java application, a Python application. And I'll give an example of that. So what we will be building. So right now I have a Spring Boot application running on a Ubuntu VM, and this is running on port 9090. I have an HA proxy above it, and this HA proxy writes to a log file. And from the browser, I will call that HA proxy, and it will talk to the Spring Boot application. In addition, and from the Elastic side, we will have 3 Elasticsearch nodes. So let me just fix this. And we will have Kibana, and we will have Logstash and Apm. So this is the way I've configured it. So there is 5 VMs, and this is the way it's configured. From your own point of view, it really doesn't matter where you put the Kibana or the Logstash or the Apm, but it's really important that you put the Elasticsearch instances on separate machines or on separate containers if you're doing Kubernetes or Docker Swarm, because this way you can get some reliability, and if one of the nodes fail, the other one can take over. So Elastic uses something called the Raft protocol. There's like a modified version of the Raft protocol, and what it does is, if one of the nodes goes down, one of the other 2 nodes votes among themselves and makes themselves the master, and then they can do cluster coordination among themselves. So doing this master takeover or main takeover, this is relatively easy in Elastic. It's there in a lot of other NoSQL solutions as well, but it's, from what I've seen, it's not available in most RDBMS solutions like MySQL and Postgres. You need to work around that, but Elastic has this out of the box. And for that, you need an odd number of master machines. So these Elastic nodes, these are actually have data, master, and all the capabilities that come out of the box. So what people typically do is that you set up an Elastic Stack cluster in such a way that each node has all the capabilities, unless you know very well what you're doing. In that case, you have separate master nodes, you have separate data nodes. But if you're just starting out, you're doing for the first time, it is strongly recommended that you just strongly recommended from my side that you actually go ahead and set up the default configuration where each node is a master node and a data node both. And then eventually, as your cluster grows bigger, your needs grow bigger, and you're more familiar with the cluster and its operations, then you can create dedicated masters and dedicated data nodes. If you want to get some like rule of thumb, so this is actually being set up on-prem, but Elastic has a cloud-based model as well. So you can deploy it on the cloud. So you can get, without using a credit card, you can sign up and you can create a cluster. So like 2 minutes ago, like more like 10 minutes ago, I set up an Elastic Stack cluster. And when it gets created, you can go in the cluster and you can go and click edit. When you click edit, it will show you the configuration that it has used by default. So if you see over here, it's showing that there is a data node over here. And if you go to dedicated masters, it says that there are no dedicated masters, right? So they're automatically added when there are at least 6 Elasticsearch nodes. So this is running on AWS. So if I want to add 6 nodes, I can't add them yet. And I need to take the RAM per node all the way up to 58 GB, and then I can add 3 nodes. So there are 2 zones. So this is an availability zone or a data center for AWS. So 2 zones mean that there are 6 nodes. So there are 3 nodes per zone. And only then you will see that, it says that, okay, now you can create a dedicated master. So the rule of thumb is that you shouldn't, unless you really know what you're doing, don't add dedicated master in the beginning of your cluster design. So I ran a cluster that was doing something like 1.5 million ingest reads per day, and we had 3 nodes, and we increased it up to 5 nodes, but we really didn't have any issues with that. Okay, so we have a comment. I'm new here, guidelines will become expert at ES. So the reason for doing this session is for the people who just joined is that there are a lot of people who are coming in and trying to use Elastic and they really don't know where to begin. So my job is to actually help people, try to find some footing where do you actually start. So that's the basic idea. So we have 3 Elasticsearch nodes over here. They're master and data both. We have on another Ubuntu VM, we have a Kibana node. And another Ubuntu VM, we have a Logstash and Apm Server node. What these are, I will explain them as the session goes on. And if you see this, basically from here, we can go to here. So what we will be doing is, we will have, so Elastic has these products called beats. So beats are small, lightweight daemons which run in the background. So we have something called Filebeat, which we install over here, and this will read HA-proxy logs. So the HA-proxy server over here, it's actually writing to disk, and we have a Filebeat service which will read from this disk line by line, and it will send this onto Elasticsearch. We will also have Metricbeat, Packetbeat, and Auditbeat. These are 3 other products, separate products, and these read the VM itself. So you don't need to point to a file, they talk to the operating system itself. And Metricbeat does essentially what top does. So if you want to look at the state of your, especially your CPU, your memory, and your disk usage, Metricbeat will record that every few seconds and then send that to Elasticsearch. Packetbeat reads your packet interface, your network interface, and Auditbeat basically looks at the audit logs of your system. So who logged in, who didn't log in, who used a wrong password to log in, those kind of information is there. So if you want to comply based on audit for your environment, for example, you work for a bank or a telco and you want to have a system that can implement a certain level of auditing capabilities, You can install Auditbeat on all of your machines, which need to be audited, and you can send their stats to Elasticsearch, and then you can view them in Kibana. So I will show this for one VM, and you can essentially migrate it to multiple VMs. And lastly, just to show this, who is talking to who. So I just showed you Filebeat, which leads from HAProxy. This goes to Logstash, and then it goes to Elasticsearch. So the reason and then Metricbeat, Packetbeat, and Auditbeat, they send it directly to Elasticsearch, and then we have something called an Apm agent, which send it to an Apm server and goes to Elasticsearch. So what is essentially happening over here is that Metricbeat, Packetbeat, Auditbeat, the logs the data that they read from the VM, that doesn't need to be transformed. It can be sent directly to Elasticsearch. If you want to transform it in some way, there is a capability on Elasticsearch node itself. So it's called an ingest node or ingest capabilities. You can do that over here. But there's another thing called Logstash, which is another separate product in which you can send the data that Filebeat has read, and you can modify it over there. The good thing about Logstash is that you can persist the data to disk. So for some reason, if your Elasticsearch goes down, or there's some other issue on this side, then Logstash will keep persisting the data. So by default, it persists inside memory, but you can also persist to disk. And you can set the size for the disk to a few GBs or however much you want, and it will start writing to disk. But when it gets to the end of that memory limitation, then it rolls back and starts rewriting the old file. So that is something you need to be careful about, but Logstash has that capability. Another thing is that, so over here in Elastic, like I said, there's something called Ingest Log. So we are not going to ingest node, ingest capability. So we are not going to use that, but what it can do is there is a language called Painless, and you can run that inside there. And it's a pretty powerful language, and you can modify your fields. For example, if you have a string field, you want to turn it into an integer field, you can do that over here. You can do the same thing in Logstash, but there's a difference between them. For one thing, when you do this ingest operations on Elasticsearch, that puts some load on the node itself. So that is something that you need to take care of, that, if you're doing ingest and you're doing indexing of the data as well, you don't want the node to be overloaded. So that is something that needs to be evaluated while you're making that decision. With Logstash, you can do the same kind of things. You can do different operations. You can also do something like turning a string into an integer. The good thing about Logstash is that it can talk to systems outside Elastic as well. So if you want to talk to a MySQL database and you want to take some data from the MySQL database and put it inside your data that you're receiving from Filebeat, you can do that in Logstash. In the ingest node over here, you cannot do that. So with Logstash, you can talk to systems outside other than Elasticsearch as well. And that's a very powerful and interesting capability to have. And the other good thing about Logstash is that you can write in Ruby actually. So if you know Ruby, or if you know any other higher language, it's actually very easy to write very complex logic and run for loops and all those kind of things. And that's a very powerful capability. So the last thing is the Apm Server. So what the Apm agent does is it does something called distributed tracing. So if I want to show you what that is. So in Elastic, you have something called APM, Application Performance Management. If you use something like Jaeger or Zipkin, it does something similar as well. So what it does is so for every transaction, it shows you something like this. For example, there is a HTTP call for orders, and in that you have a get call, and you have a get API orders call, then you get API call, and then so on. So you get this very, really nice kind of a stack of services that are being called and how much time each of them takes. The whole request, or in other words, in APM terminology, or tracing terminology, is called a trace. So this is a trace, and inside there is a span, there's another span, there's another span. So you know how much the whole trace takes and how much each of the spans takes, right? So that's a very good way to figure out which part of the application is actually slow. So for example, you had an orders request, and the HTTP get request took only 2 milliseconds, but the MySQL query took 50 milliseconds. So you would know that, my MySQL is very slow. I need to look at that. Maybe there is no indexing over there, maybe some other issues over there. So I've actually used this in one scenario where our Postgres query was taking a very long time, and I figured out using this distributed tracing, this APM agent that we use. So the APM agent over here, this is actually not run as a daemon. So there are different ways of running it. The way we will run it is that we will attach it directly to the jar file, to the Spring Boot jar file, and we will use that to send the APM data. So I will just go on and start the installation process. So basically what you do is, so I'm running this on AWS. So I have 3 nodes, and I have a Kibana node, and I have an application server, an Apm, and Logstash on this machine. The reason why I call it unsecure is that the installation that I'm going to show you is an unsecure installation, which means that there is no username password on this. So if you want to set it up on your own system, make sure that it's behind a firewall, it is inside a DMZ, it's not visible to outside to the internet. Right now it is, but it's kind of a demo, so that's why I have it. But there's a way to make it secure as well, but that's quite an involved process, and that deserves its own talk. So this installation is actually unsecure. So what I've done already is that I've installed Elasticsearch on node 1 and node 3, or I think node 2, and I need to install it on third one. And the process is absolutely identical to all 3. But as I go along, I will show you how I do this. So let me just confirm, and I'll just look at the IP address for this. So this is the public IP address for my machine. And I can go over here. So this is a Ubuntu machine. This is Ubuntu 20. I'm running it on, and I want to just make sure that this is running Elasticsearch or not. So for Elasticsearch, by default, if you want to talk to Elasticsearch, like with other databases, for example, Postgres, you have PSQL. For MySQL, you have a MySQL command line interface, or you use a JDBC driver or something like that. With Elastic, everything is on an HTTP REST interface. So you want to read something, if you want to write something, you use a get or a post, or those kind of commands to talk to it. And it runs on port 9200. So I'm just trying to check whether it is already installed over here or not. So if it is already installed and it is running, then it will show you, it will give you back this information. And this is a JSON object that is returned, and it's showing the name of this node. It's showing the name of the cluster, and it's showing the version number 7.9.1. So this is how you confirm that Elastic is actually running. If you want to look at the logs, you can actually go to, and you can see the Elastic service. I think I need to do a sudo for this. Yeah, so you can see the logs, and you can see what is happening inside actually. But this is not the machine, it's another machine actually. So let me just confirm with the second one. Was it this one? Okay, it's also on this one. So it's this third one which needs to be, which needs the installation. So I'll just SSH over here. So I'll just make sure that there's an Elastic over here, and there isn't. So there are some steps for installation of Elastic. So what I typically do is, if I'm doing this on a Ubuntu machine, I will go to install Elasticsearch using apt on Ubuntu. So what typically happens is that so different products like Prometheus or Elastic or any product, they have a certain release cycle, and they release it very frequently. With Elastic, the thing is that for example, the 7.8 release, it came out about 8 weeks ago, and like 2 weeks ago, 7.9 came out. So Elastic releases very frequently. So every 6 to 8 weeks, there's a new minor release for Elastic. And the minor release itself is like a completely new product. There's so many new, very nice, very interesting features. Some organizations, they actually don't update their APT repositories that frequently, but Elastic does it on a very frequent basis. So you can actually, whenever you want to install, you can install it from their APT repository as well. So the way to do this is to actually go over here and you can run this and then you can install this. So this is actually, so I went to Google for installing Elasticsearch on APT using Ubuntu. I went to install Elasticsearch build Debian package. Elasticsearch documentation is actually really good. So you really don't need to go anywhere else. Except I have some my own shortcuts. I've written them somewhere, so I use them if I want to do it on a regular basis. So there's another command you need to run. So what this does is that it takes the Elasticsearch Debian information and it adds to this file. So if I want to see it, I can actually go over here and see this. So basically what this tells us, you want to note is that if you want to get Elasticsearch packages, you get these from here. And lastly this, so you do an apt get update and this will get the latest information for the Elastic clusters and then you do an apt install. So the reason why I'm doing it like this is that on my other nodes, I actually installed Elasticsearch 7.9.1. But I think yesterday or day before, 7.9.2 came out. So when you're setting up an Elastic cluster, it's actually a very good idea to make sure that even the minor and the micro version numbers are the same. So typically Elastic is very compatible, very flexible, but it's always a good idea to make sure that the versions are the same, so that you don't run into some strange issues. So basically, what you do is you can specify the package name over here that I want to get this particular one. So I'm installing Elasticsearch 7.9.1, not 7.9.2, which is the latest one. If I just ran apt get install Elasticsearch, it would have installed 7.9.2, because that was the latest one. So what this does is it puts Elasticsearch executable in here. So you have a bin Elasticsearch over here. So you have an executable for this, and you have all these other executable as well. So these are used to set up a secure cluster. So generate certificate, key store, and then you have so these are actually used for generating certificates and setting up passwords and setting up certificates. We're not going to do that over here, but this is basically where it installs. And typically for any Elastic stack product configuration, you always have a etc and that product name is over there. So I'll just sudo and so for example, you have etc Filebeat, etc Metricbeat, so you have etc Elasticsearch over here. So the configuration file for Elasticsearch is in this file. It's elasticsearch.yml, and we can see that you have these settings over here. So what I will do is I will take the settings that I have from my other files or from other nodes, and I will use them over here. So I won't copy them, but I'll put them in one by one. So I will just look at the sit over here, so I don't have to do this. So what this does is, so I've created a cluster and I'm calling this. So I already have 2 nodes in this cluster. I'm going to add a 3rd node. And in order to make sure that it joins the same cluster, I need to make sure that the cluster name is the same. So if the cluster name is the same and they can talk to each other, then they would join the same node. So it's also very helpful because, for example, you have a 3-node cluster, and after using it for, like, this decision happened to me. So after using it for like a year, we got new customer, you got a lot of data coming in and things start to get slow. So we just added a new node with the same cluster name, and it just joined the cluster, and it was very painless, and things started improving. Another thing is that you can give the node a proper name as well. You can call it node 1, node 2, whatever it is. What I typically do is I just use whatever the host name is. And then I make sure that the host go to etc host and change the host name to the one that should show up. So that is a personal best practice, but you can use a string field over here as well. Other than that, so these are the paths to the data. So when what Elastic does is that the information that it has about the data that it's storing, the shards and the replicas and the other cluster information, it puts it into /var/lib/elasticsearch. This is a directory. So it puts it over here by default. So make sure that wherever your directory is, it has enough space. A good practice is to actually create a separate disk and then have a lot of space in that disk and attach that disk to the to your VM. And that way you will have more space than your and it won't be on the root disk itself. So the logs are created over here, and this setting, Bootstrap memory log, is actually very important because Elastic, what it does is that it uses a lot of JVM memory, and it wants to make sure that the memory available to it does not change a lot. So you need to log the memory and you need to freeze it. So the recommendation by Elastic is that whatever is the memory of the VM that you're using, make sure that it is half of that, but not more than 32 GB. So at least this is what I've read, and this is what you should use. So I always make sure that I do this setting over here, that Bootstrap memory lock is set to true. A few days ago, I was in another session, and it was a microfinance bank, and they were having problems where their performance started going really, really bad, and just couldn't figure it out. So if you use this setting, if you don't set the setting, then it's going to be fine for a few days, but after a few weeks or months, you're going to run into serious problems. So make sure the memory setting is done. So in order to I'm trying to do a production cluster in terms of memory, in terms of performance, as much as possible. And if you do these things, they should be good enough for as long as the performance of the cluster is concerned, and then you can optimize it afterwards. So over here, what I've done is that in address hosts, I've put _ATH0_local. What this does is that it looks at whatever is so if I do an IP address, so I have two network interfaces, right? So one is the loopback interface, and one is the ETH0 on which the private IP address is available. So when I do _ETH0, whatever is the IP address mapped to this is available. It gets bound to this particular IP address and also to the loopback address. So you can basically do curl to 172.31.20.241, 492.200. You'll be able to do this, and also you'll be able to do a localhost 9200. If you want to be able to do both of these things, you should make sure that you do this. You put both in the network host, and this is an array, and you can put more than one as well. The third setting is, so this is discovery seed host. So this is a setting which says that which nodes are actually available for the cluster, and I'm going to add all three of them over here. So these are private IP addresses of the three nodes. So the node I'm actually using over here, and the other two nodes as well. And then, so let me just check maybe the chat messages. Open tracing, cloud native. No, this is not cloud native actually. So this uses the Elastic stack. So Elastic stack's on Apm tracing. It is actually compliant more or less with open tracing with most of the things. But in cloud native, some of the products that they have, for example, AWS has application gateway or firewall. they have, so firewall, I'm pretty sure doesn't have support open tracing, but if they do support open tracing, then they can be part of the open tracing flow. But this is not cloud native. This is actually everything is being done on-prem. So over here, so the other setting, the first setting was that these are the initial list of hosts to perform discovery for this node. So these are the nodes that will talk to when it starts up, and it needs at least one master node, which it should be able to reach in order to join the cluster. So this is one of the node private IP addresses of the node. And the other setting, we don't need to do any other settings. So this is actually for this file itself, this is pretty much what you need. There are a couple of other settings as well. So there are some JVM settings that you need to do in order to make sure that the performance is good. So we will give certain amount of memory to this particular JVM for Elasticsearch. So if you want to figure that out, you can see that how much memory you have. So this particular VM has about 7.8 GB, about 8 GB of memory, and it is about 6 GB free right now. So it has about 8 GB memory. So I can give it like 3 GB, and that shouldn't be a problem. So it's slightly less than half, but it shouldn't be more than half. So I will give it 3 GB memory for this particular node. There are some settings for that. So this is so I'm not plugging my own blog, but actually I wrote these down for a quick reference because I ended up doing this so much that I just wanted to down. So these you can actually find it at this URL as well, but you can also, these are actually there in the Elasticsearch documentation as well, but it's a bit scattered. So it's a bit tricky to actually go there and find it. But it's not that much. So what you can do is you should go to Atc Jvm Options. So this is the node we're doing this on. So we go over here and we change the memory over here. So the XMX, we change it to 3 GB. So this is the amount of memory that they should have. And then you go to the security limits file, and you want to make sure that the limits are set to unlimited. So this is for Ubuntu. For CentOS or Fedora-based system, it would be slightly different. So we are telling it that memlock should be set to unlimited. So these are JVM related settings. So this directory does not exist. We just need to create this directory, and then we create a new file called override.conf in this directory, and then we add this line. So these are 3 additional settings that you need to do. Then you can do a daemon reload, and then you Elasticsearch start. So this will start Elasticsearch, and hopefully it will join the cluster with other 2 nodes. So this will take maybe a minute and a half. So let's see what happens, and fingers crossed. So I will just look at the logs. And let's see if the service started. We can go localhost 9200, service started, but we want to see whether it's part of a cluster or not. And we want to see whether all 3 nodes in this cluster have the memory setting done correctly. So in order to do that, you can run this command. So it's what it does is so Elastic has different APIs. So there's a node API, there is an index API. So this nodes API, it actually tells you what is the condition of each node. So I do a query for that, and then I check whether for this particular attribute in the data that is returned. So I do that, and it shows me that there are 3 nodes, and for all 3 of these nodes, mlock is equal to true. It means that the memory has been locked. If you want to see the complete output of this, you can. And so it actually comes out like this, which is just useless. You can't do anything with it. So what you can do is you can always put a pretty at the end of this, and it will give you a nice formatted JSON. And this is the output that we just saw, but we actually filtered it for this particular text. And this is how we got. So we have 3 Elasticsearch nodes now. If you want to do this for the other 2 nodes, you just repeat the exact same process. So there's no difference. You can actually even if you go and look at this file, this is actually, there is nothing over here which is specific to this particular node. So you can just copy paste this file as SFTP over there and then just restart it as well. So that's equally convenient. So we'll install Elasticsearch over here. So the next thing we're going to do, we're going to install Metricbeat and Metricbeat, Auditbeat, and Packetbeat. And I'm going to do this on this machine. So over here, I have an application server running, and I want this machine to actually send its own metric information. I can do this on any machine; it's absolutely fine. But I'm going to use this particular machine. Ideally, you should be doing this on every machine of yours, because you want to see what is happening inside the system. It's very important to keep an eye on that. So I will just SSH to over here. So on this machine, if you want to install Metricbeat, you can go over here. You can do the same thing. You can do install Metricbeat, Ubuntu package. We can go to repository for Apt and Yum, and we can go over here, and it's the same thing that happened last time. So we need to do this. We need to install this package. We need to set the repository definition, and then we do an update and do a apt get install Metricbeat. So I've actually done all these steps before, so I won't do them again. But this step I have actually done as well, but I will still do this again just to show. So basically, what you do is you install this, and this is already installed. So the process is very similar to setting up Elasticsearch. You just need to run these 4 commands and this 5th one also, because you want to make sure that the service is restarted whenever your VM is rebooted. You want the service to restart, so this is set to auto start. And then, for example, in Elastic, we had, let me just use here. So on Elasticsearch, we had /etc/Elasticsearch. Over here, we have /etc/Metricbeat. Right? So in Metricbeat, what we have done is that it has a setting file over here, which is this file. So with these settings, you really don't need to do much with these settings. You can set them as they are. So Metricbeat has some modules as well. I won't go into those, but those are specific for different services. If you want, you can give some tags to this. So the data that you have that comes out, it can have certain tags. For example, the machines that have Metricbeat installed on them, they might be production machines or staging machines. That kind of information can be there. That information can also come up through these attributes as well. And then you have dashboards. So there is a setup.kibana, there is a output.elasticsearch, and output.logstash. So this is actually important for you to know, because so we already have Kibana running somewhere, right? So we have Kibana running on this particular port. And what I've done is that I'm telling Metricbeat that the Kibana instance is running on this host. And this is actually used to load Kibana dashboard. So Kibana is a visualization for Elasticsearch, and it is used to display the information that is actually received from different sources. I can give you a visualization. We'll set it up later on, but basically it looks like this. So you can go and see the logs that you have received, for example, throughout the day. And you have something called dashboards. So the dashboards are pre-built visualizations, which you don't need to build them yourself. So Elastic has built them for you. So there are Filebeat dashboard, there are Metricbeat dashboards. The Metricbeat has their own dashboards. And you don't need them, but if you want, you can use Metricbeat to install them for you. The downside is that you get a lot of these dashboards which you won't be using, and you would want to delete them afterwards. But the good thing is that they already have like really good dashboards, and they're just available out in the box. So in order to load the dashboards, what you need to do is you need to make sure that setup.kibana. So by default, it's like this. So you can go over here, you can put your own host name, and you can run Metricbeat setup, and then dash. So what this will do is, this will talk to the Kibana instance that you've configured, and it will install those dashboards inside Kibana. So what is actually happening is that it uses the Elasticsearch in a cluster that is being run in the background, and those information for those dashboards is basically set up over there. And then Kibana can read those particular dashboard definitions and display them because it understands them. But it's essentially data inside an Elasticsearch cluster. So Kibana itself does not run its own database, doesn't have its own memory, but it actually talks to the Elasticsearch cluster and stores all its information over there. So this takes a few, I think it should take like half a minute maybe, but this is a bit of a time consuming process. So what this will do is it will show up over here. So let's do a Metricbeat, and we can do a Metricbeat. You don't have Kubernetes, you don't have, so we can do a Metricbeat system. So if you do a Metricbeat system, you can overview ECS. So ECS is actually Elastic's own standard for data, the way it defines the data, the way it handles it. So it's called ECS. And we can see different visualizations for the Metricbeat data. So I just started this, so I think it should show up. So I can change the time filter. I can say, show me for the last 15 minutes into load. And I think Metricbeat is not running, so that's why it's not showing up. But these are the dashboard that get set up when you run this, right? So if this process is completed, and what we can do is we can go back and we can tell this Metricbeat that where is the Elastic which is running. So you can send it over there. So you can do that by setting an array of Elasticsearch nodes. So what we've done actually over here is that we've told that we have 3 Elasticsearch nodes, which are all data nodes, and you can send to any one of them. So what it does is it talks to one of them and then sends the data to that one. And if I've actually not tested this, but I'm pretty sure that if one of them is not available, it talks to the other one and sends it over there. So you can give it an array of Elasticsearch hosts for output. So for Metricbeat, typically what I used to do was I would send it directly to Elasticsearch. I would not use Logstash, and I'll tell you why later. So once you've set up the private IP addresses of the 3 nodes, so these are 3 Elasticsearch nodes, one of them which we just set up. So these are their private IP addresses, and they talk on port 9200 to each other. They talk. So basically, Metricbeat talks to them on port 9200. To each other, they talk on port 9300. So we're just sending it to 9200 over here. So we will just service start Metricbeat. Service Metricbeat. So we can see whether it's working. Seems to be working. It's 9:45. Not found version data user. So there's an error over here. I don't know what it is, but let's see. I think it's trying to talk to Nginx, and it can't find that. So I did some setting for Nginx as well, but I think I changed it somehow. But it should still send the information. So if you want to see how it's So let's just go over here and see what's happening over here. So in the dashboard, you can see that this data just flowed in, right? So it's showing that this is the amount of disk that has been used. It also shows you traffic, Metricbeat does, and it shows you that top host by CPU are these. So I have only one host. It's showing that it's using 0.5%. It's green. If it goes up, then the color is going to change. So that's a nice visual way of seeing what is happening. You can also click this link. You have a host overview, and you can get all this information. This is like a very nice looking top that you have, and it shows network information as well. And then you have, if you have containers, it shows you what's happening inside containers, but I think this is a different way of setting this up. I'm not sure how these containers are showing up, but maybe I have container D running over there. But I think it's a different concept. So I'm mainly installing and testing this on VMs and dumbing out on VM, because if you go to Docker containers, then that's a different game altogether. But what this does is it sets metric information of the system to Elasticsearch. If you want to see how frequently this data is collected, so you can go to the module.d directory, and you have all these modules. So you can enable them, and Metricbeat will start using those modules. So one of them is always enabled by default. So if you put a .disable behind it, it's disabled. But if you remove that, then that becomes enabled. So this one is always enabled. And if you go over here, you can see that it reads every 10 seconds. And these are the metric information: CPU, load, memory, network, process memory, it sends these out. And also send information for file system and FSTAT. So you can also check whether your disk is getting filled, and if it crosses 80%, you can generate an alarm for that. That's possible as well. So the alarm capability, it's not, so for alarm capability, you want your Elastic to send alarms. So it varies. What kind of alarms can you send? Some of them are there in the paid version. Some of them are there in the free version. But for either of them, you need to enable security. You need to enable expect security for that. So I won't be showing alarms, but right now you can see that this information is being read every 10 seconds, and this information is being read every 1 minute, and it's being sent to Elasticsearch, and from Elasticsearch, Kibana reads that. So that was Metricbeat. So similar to that, we also have so there's another thing I want to show you. So this is actually a dashboard, but something that you end up using very frequently, it's this Discover tab. So if you go over here, so you have a dashboard over here, and then you have a Discover over here. So what Discover shows you is how frequently your data is coming in. So it adjusts this time automatically. So I said, show me the last 15 minutes, and it's showing a timestamp every 30 seconds. So every 30 seconds, you have three records coming in. And this is actually from Filebeat. So we can change the index. So this was actually Metricbeat. So if you go to Metricbeat, we will see that these are the number of records that are coming in every 15 minutes. And this is actually the log that you saw, the information that you saw over there. This is actually in the form of structured log. So by structured log, the good thing about this is that you can actually run a query on it. So for example, I want to see logs for service type system. You can run a query for anything. So what you can do is you can go add a filter, and you can do service type is system. So it will apply that query, and it will filter for those items. In our particular case, I think it matches all the documents, so that's why it shows up. So that's how you query documents. Another way of querying documents is that you can write it over here. So you can do a system dot, for example, we can do user name is equal to root. So we can do like user dot name is equal to root. This is actually called KQL. So this is another way of querying documents. Um, you can use a filter over here. You can do a KQL over here, and then you can save that particular view. And then you can, for example, let's call it my view. And then you can share it with other people. So you can go to this permalink and you can do a short URL and it will create this short URL, and then you can send it to anyone and they can open this particular view and see that particular view. You can also embed time information in that. So that is also very helpful as well. So we installed Metricbeat, we started Metricbeat. So there's another thing that I want to talk about. It's that, so the thing you see over here, Metricbeat dash star, this is actually called an index pattern. So when Elastic wants to search through a certain type of log files, it needs something called an index pattern. And for that, you need to go over here, go to stack management, and then you go to index patterns. So index pattern is actually relevant to Kibana. And Kibana uses this to actually um, show a visualization. So these are some of the visualization patterns I've already built. So this one is duplicated. So you can, I think when I install this right now, it duplicated this. But what you can do is you can create your own index pattern that match different kind of patterns. So I will just delete this one. And I will, and basically what you can do is you can go over here, create index pattern. And for example, if I want to do a Metricbeat star, so it will show you that these are the indexes that will match. So index is kind of like a table, and when you create an index pattern, it can read inside those tables. So this is how you create it, and then you can go to the next step, and then you will tell it whether it is time series based. If it's time series based, you can tell it that this is a timestamp value for this, and you can create an index pattern for that. And once you create it, and this is a regular expression. So if you know regular expression, you can create an index pattern based on whatever you want. Then you can go to the Discover tab, and you can use your own index pattern that you created to show that. So in the beginning, there is no index pattern. So unless you load Elastic through dashboards, you need to create it by yourself. I'm not really sure whether loading dashboards creates the index pattern itself as well. But if you go over here and there is no index pattern available, then you can just go ahead and create it from stack management and index patterns, right? So we don't really need this, so we can just go ahead and delete this. So in addition to that, there's another service that we will install. It's called Packetbeat, another one called Auditbeat. So installation for those is very similar. So I think we know this by now already. So we can do I've already done these steps. So we will just do it. So to people who are joined just now, maybe or late, you can go to this Metricbeat, for example, and you need to install the public signing key. You need to install these packages, and then you can install that particular beat that you want. So we installed Metricbeat already. We can install Auditbeat, and again, since 7.92.2 has been released, I want to make sure that the version is the same. So I do apt install Auditbeat. And this has already been installed, but basically this gets installed and it's available in etc Auditbeat. and we have auditbeat.yml. So again, over here, I did not change any of the other settings, but out of the box, it tells you that it checks for file integrity, it checks for host information, login information, um, and there's some other settings as well. And then you can tell it to send it. You can do a setup on Kibana if you want. You can load dashboards. I'm not doing that right now. And you can do an output to Elasticsearch. If we want to set the dashboards on Kibana, we can do that as well, but it's very similar to the previous one. Actually, let's go ahead and do that. So I haven't done this. So Metricbeat. I just want to look at the Kibana settings. So I will look at the Kibana. Okay, so this is the Kibana URL. So Kibana doesn't run in a cluster, right? So Kibana is runs on a single node. You can have more than one Kibana nodes, but they don't talk to each other. So let's put this over here. So you do a setup at Kibana, you set the Kibana hostname, and then you do an Auditbeat, and then you do a setup. It's working. So this will load some Auditbeat dashboards. So what Auditbeat does is that it gives you really nice security information. So Elastic is actually focusing a lot on system security, and there are different ways of ensuring that your system is secure. And Auditbeat is one of those very important parts of the ecosystem which is used for this. So this is I actually so it uses a mix of Metricbeat, Packetbeat, Auditbeat for the security section. So it has a dedicated security section. Before this, we used to be separate dashboards, but now Elastic has this dedicated security section for Auditbeat and other information that is available. So we install dashboards, and then let's just do a service start Auditbeat. Service Auditbeat commits and all. So this will set Auditbeat information, and we can actually go and see whether we have any audit. So this actually shows up the last dashboard that you loaded. So we'll just go back here and see, okay, we have some Auditbeat information. So let's say Auditbeat system overview. So what's going on over here? So I just installed it, and I don't think it was running already. So let's do a last 15 minutes thing. Let's see if it shows up. So actually the memory that I'm using, that's only 3 GB. You need like 8 to 12 or 16 GB VM, and you can give it like 6 or 8 or 12 GB to the Elastic itself. So it's showing that it's reading some information regarding Auditbeat. So they're showing you which packages are installed. You can check for secure or unsecure packages. You can look at the hosts that are being monitored. So only one host that is being monitored. And you can look at logs. Has any tried to log in to the system in the last 15 minutes? Okay, there are 2 login events. And these were at 9:25. So I actually logged into this machine. So this is so I don't know where this came from, but basically, if I do something like, for example, let's go out of here, and I will try to log in with, just wrong username. It's saying permission denied. So this should show up over here that somebody was trying to get into the system, and this event shows up over here, and so there was a logout event that came up over here, and it takes a few seconds to consume, and there's another event over here, and they're saying that somebody called Sami tried to SSH from this IP address, and you can generate an alarm based on this, or your system guys can look at it and say, that something fishy which is going on. Somebody trying to use this, go into our system. You can also look at all the users that exist on your system. So in this particular system, we have 38 users, and a lot of them are system users. And you have processes. You can see what processes are running on this. So this is actually for Ubuntu Linux machine. I'm not sure if Auditbeat does the same thing on Windows machine or not, but Windows machines also have something called WinLogBeat. Just like Auditbeat and Metricbeat, is something called WinLogBeat, and you can install that, and that will give you a lot of information as well. That reads Windows logs. Again, I'm not sure if Auditbeat audits the Windows system as well, but for Windows, you have that additional beat available as well. So the third one that we're going to do is, we'll look at the time. So the third one you're going to do is called Packetbeat. So it's just, so with Packetbeat, you can drill down into the details of a particular packet, and it gives you a lot of information and also helps you with the overall security of the system. And again, 7.9.1 is installed. The setting for this is in packetbeat.yml. I think it should be a bit familiar by now. So we have setup.kibana, and we have output going directly to Elasticsearch. So I've already installed the Packetbeat dashboards, and we will just start the Packetbeat service. So what this does is this. We can go over here and look for Packetbeat information. So I think you can appreciate that, like in, I think, less than an hour, we have a system monitoring, we have audit logging, and we have all these like really cool things that are available. And with Packetbeat, you can do a lot of cool stuff as well. So for example, I'm not sure why this is not showing up, but this does show up. So you can see on a map where your sessions are being originated from. And there's other packet level information that is also available over here. So you can check out network flows, so which part of the network is talking to who. This hasn't been running on for so long, but if it had, that showed like very nice visualizations. So a lot of times you don't have, I mean, some people don't have the knowledge, some people don't have the time to build these visualizations, these dashboards. So you can get them out of the box, and you can also use them as an inspiration to build further visualizations. So actually this will show up later. Let me just try something. So I think I have a hello world application running somewhere. So I just did HTTP request over here, and let's see if it shows up. I think if you do a refresh over here, a couple of seconds. Okay, it's not showing up, but it looks at HTTP traffic, and that HTTP traffic can also show up on a map. So you can see which part of the world is you're generating the most amount of traffic from. So actually I have it over here. So I think I ran it earlier as well. It's not showing up. So this is something that needs to be investigated, but basically you can have you have a map as well, which on which this shows up. Let me check. Okay. So we've already installed these beats which send the data directly to Elasticsearch. So next thing I'm going to do is I'm going to show you Logstash and Apm, and so what I will do is I've already written the configuration for that. I'll just walk through that, and if there are any questions, I can answer them. But what I have done is that, so what you can do is you can go ahead and install Logstash, and I think we're already on this machine. Let me just confirm. 172.31.16.39. Okay. So you can do the same thing that you did over there. So you can do install Logstash. Install. I think it's called Logstash. Install Logstash Ubuntu apt. So it's always a good idea to go directly to the Elastic documentation rather than to DigitalOcean or somewhere else. So the documentation is actually pretty good. So oh, 7.9.1 for Logstash was not found. So we can just check what happened. So if it's already installed, it should be in Logstash. I already installed it. So all products are actually installed in user share. So you have Elasticsearch in user share, you have Filebeat in user share, all those as well. So I guess you cannot specify version number exactly for Logstash. I'm not sure why this happens, but 7.9.1 is already installed. So with Logstash, the thing is that it's slightly different from the other configurations. So if you remember, you went to /etc/ whatever was the product name, and then we did went to, for example, Logstash, Metricbeat.yml, right? So for example, we have Logstash.yml. But over here, you really don't need to do much, right? So for example, I told you that what Logstash does is you can send data to this, it queues that, and it queues that inside memory or inside on disk. So if you want to queue that on disk, then you need to change this to persisted, right? So what this will does is it will write to disk. So it's always a good idea to do this because no matter how much memory you have, if something happens to your Elasticsearch cluster and your Filebeat is sending data, then it is going to become, the time is going to come when your memory is going to get exhausted and your older data is going to start get overwritten. That happened to me once, so I know that from experience. So it's always a good idea to persist it to disk. So we have Logstash installed, and we have, let me just check, where is my Filebeat? So my Filebeat is on the same server. Okay. So we have Logstash installed, and before Logstash, actually, I want to talk about Filebeat. So Filebeat again is installed using the same process. So we can do a Filebeat apt get installed. You do all the other settings, and then you do a Filebeat. So Filebeat installed. Now what Filebeat does is, so this is actually the kind of the interesting part. So in Filebeat, you can configure, you can first of all write the dashboards. So like I did the dashboards for the other, you can do dashboard for Filebeat. I haven't actually used Filebeat dashboard because I didn't really need them, but what Filebeat does is that, for example, in this machine, I have a node application that is running on port 3000, right? So it's a simple application. It just sends out a hello world, right? And I have an Nginx service that is running on port 80, right? So this is a reverse proxy. So if I do a Nginx, so it's never, then it basically what it does is it listens to everything on port 80 and it just reverse proxies it to port 3000. And this is actually what shows up. So this is my Nginx talking to my node application. Now what I want is that these log files that these are being created in this location, var log Nginx, for example, access.log. So I want to see who is accessing. I want to get store the logs and structure them properly, and then access them. So I ran this, and it actually, this is my request that just came in. So I'm using a Mac, so just show that, and it says that it's got to get slash. So usually what you want is when you have log files that are being generated on disk, you want to be able to access them in a visualization. So you can use Filebeat for that. So we can tell Filebeat to use the default settings for Nginx and read these files. So we can do that by going into /etc/filebeat, so filebeat.yml, and we can. So I will just disable this. I'll come back to this in a minute. And so what we've done is that we've told Filebeat that, send your output to Elasticsearch. We can send it to Logstash and we can send it to Elasticsearch both. But we are saying that you send it directly to Elasticsearch. And what we've done is that in Filebeat, you have a conf.d folder. So if you go over here, you have, no, sorry, this is etc Filebeat. Here you have a modules directory. So I told you that I'm running an Nginx service. So there's actually Nginx module over here, and it's enabled. It's not disabled. So you can see that there's no disabled at the end of it. And if I go and open this, I'm saying that I want you to access the access logs, the error logs, and there's something called an ingress controller, which is for Kubernetes. So I just tell it to access the access logs and the error logs and to parse them and convert them and turn the integer field into integer and do all that stuff and send it directly to to Elasticsearch so that I can see it in Kibana. So I have this. So just to tell you again, so I have this filebeat.yml file where this part is actually by default turned enabled is always false. So when you open it for the first time, it will already be false. What you need to do is you need to go over here and set the Elasticsearch out. So you need to set the output.elasticsearch host to the host that you have, but don't set the Logstash output. So in Filebeat, you can only send output to either Elasticsearch or to Logstash, not to both. So what we are doing is that you need to send it to Elasticsearch. So I did this setting. So I set output to Elasticsearch, and in modules, I renamed the. So it was like this initially. So I renamed this to this, and inside, I made sure that access log enabled is true and error log enabled is also true. So I will now start Filebeat, and this should start processing the feature request. So I will just do a /var/log/nginx access log. So I'm not sure where this is coming from, but basically what we're looking for is this, right? So this shows up over here. And this should actually show up in Kibana because this request should be processed by Filebeat over here. And from Filebeat, it should go direct to Elasticsearch as you configure. So if we go over here, we should be able to see it. So I will go to the Discover tab. And it's showing, so this is something that you might see, undefined is not a configured index pattern. So what happened was, if you remember, I deleted Metricbeat. And this is actually not the name by which Elastic identifies its indexes. So this is kind of a label. So even if you delete something and you create it again, if you come to this dashboard, it will remember the old index ID. So that's what happened. So don't worry about it if you see this error. There's nothing to worry about. So we are sending that Filebeat information to Elastic, and it's saying that there's no result match to criteria. It's probably because of this. I hope so. Fingers crossed. And basically it's showing a lot of data. So I guess it's been running for a while now. So what this does is, so we just ran it now, and we should be able to see some Nginx information, and these are the Nginx logs that we just generated, right? So what this does is that it does these things like it takes out the source IP, the timestamp, the URL information. So the server status actually, not the one that we're looking for. So I think this is some service. Let me just run this again. So I will go back to this last 15 minutes. And let's run this. And I hope it shows up. So okay. So what happened was, this was the actual request that I sent, and what this did was that it got that request, it parsed it, it processed it, and it even ran this geolocation on it. So Elastic has this GeoIP database that it uses for lookup, and it used that to also infer this additional information. So if you want to do it yourself, it's probably pretty time consuming, but it can do this kind of really cool stuff where it can find out, what is my IP address, what is the telco provider name, even my lat long is over there. So you can get all that information just from enabling the Nginx module. Now, if we go to audit log, I think this should show up. So Elastic has different data types. So this hash shows that this is an integer. This T shows that it's a text type. This is a timestamp. And I think this is Boolean, yeah. And this is a GeoIP. So the GeoIP is a particular type, and you can, and this is specific to Elastic. So if you identify a document as GeoIP, it will save it as a GeoIP location. But this information that you see, this is separate processing. So you need to explicitly tell Elastic that I need to process this additional information and based on this GeoIP. So Nginx, the Nginx module is actually smart enough to do all these things for you. So if you go to the audit log that we just did, so I go to security overview, and we were doing this audit log test, and I think that was the audit log dashboard. It was a packet beat. Yeah, I was hoping that would show up over here, but it didn't. So, so I don't know. So there's a way for that to show up over here. But what you can do is, I mean, it's kind of a shortcut, but what you can do is, just make sure that I have fewer logs so they're quicker to load. So this GeoIP that I just came here, it's somewhere over here, source or geolocation. You can go over here on this filter and click this visualize button. So it will create a map for you, a new map for you, and populate that information over here. So I just showed you that, this came from Pakistan. But if I had like lots of different people accessing it all over, then all of those geopoints will show up over here, right? So that's the one thing. So that was Nginx, uh, Nginx, Filebeat using Filebeat's own modules. So the other thing that we're going to do is we also have an HF proxy service running over here on port 8080. And that HF proxy service writes to disk. So I've configured, so HF proxy typically doesn't write to disk, but I've configured in such a way. So if I do a refresh over here, the service is running, there's nothing behind it, but you can see that this is running. And what this does is /var/log, which is why I tell it to write it over here. So if I do this, log file. So I want to see this log file generated. This log file is structured, so I can query it, I can process it, I can build visualization over it. And I will use the same Filebeat for this. But what I will do is, instead of using the, I think there's an HF proxy module as well. Yes, so there's an HF proxy module as well. So if I use this, it can do a lot of cool stuff for me, but I don't want to use this. I want to use Logstash for this, just to show that, you always don't have a module available. You can have any kind of data. So it doesn't need to be an HF proxy file, Nginx file, or Apache file. It can be like telco CDR data, or it can be any other kind of data, some CSV file, some Excel file returned to CSV, and you can use that. And you need to be able to know how to do it without using an available module. So we will actually use the same Filebeat. I just change it. And the way I will change it is that I will, instead of sending it to Elasticsearch, I will say that, send this to Logstash. Right? So just make sure that indentation is right. This is YML, and YML is very sensitive to indentation. So we are telling it that, there is a localhost 5044, there is a Logstash running. This is a default setting for Logstash. And let's see if this is running. So I'll just do a localhost 5044, and so there's no Logstash running. So we will start Logstash in a bit. Another thing I need to do is I need to make sure that this is enabled. So what this does is, if you want to explicitly enable something and explicitly set the file information, you need to go to this section at the top, Filebeat inputs, select type is log, enabled is true, and give the path. So you can give the path to a directory, it will read everything, or you can give the path to a particular file, for example, here. So I given a path to a particular file over here. So this is the log file for HF proxy, which is being generated on this. So I did this, I changed the output from Elasticsearch to Logstash, and that's it. And one thing, just to be sure, I will do is I will rename this to, I'm not sure if it's going to make a difference, but and I will Filebeat restart. So Filebeat will actually start reading the HF proxy log file, which is here. Show it again. It will start reading this file line by line. And Filebeat is actually quite intelligent. So if you, so for some reason, if HF proxy is not listening, it will send it to, so for example, so if Logstash is not listening, Filebeat will send it to Logstash. It's not listening, it's going to remember which was the last record that got consumed by Logstash. And it will keep retrying. So it does something called, it guarantees at least once delivery. So in that way, it's quite intelligent. So we will go to so I install Logstash, and Logstash configuration is in etc Logstash. And so like I said, so Logstash configuration is actually like this Filebeat information that I've received. You don't actually change this in Logstash. So you have something called conf.d directory. So any file over here with a .conf extension will be used for the consumption of the input data. So I have an HA proxy over here. So an HA proxy configuration. So what this does is, so you have three main sections. One is the input section, one is the filter section, which I've written twice. You can use one filter section, you can use more than one, it's fine. And you have the output section. So what this does is it says that I'm listening on port 5044 on the local machine. And when I receive that, I will use a grok pattern. So a grok pattern is something which takes a particular file, a particular line, and it transforms it based on a certain regular expression pattern. And what I'm doing is that you can then take that expression and you can add additional data to that. So what this does is that it takes the, sorry, not too enthusiastic. So what this does is, I'll just remove this, it's not necessary. So what this does is that the HA proxy log that we just saw, it gets sent here by Logstash. It goes into this grok section, which basically opens it up. So for example, over here, as we could see that, so from a line of text, it becomes structured data. Like this. So this data is actually structured. So it has, you can query it, and it's the form of a JSON. So this does that. Then you, for example, I have a particular field that is being received over here, which is, so this is HE proxy information. So this is actually time backend connect. So I can use Logstash's own internal language to do these kind of things. So I can convert a field to integer. This is a string field. And I can also run Ruby code. So you can use this filter input, and then you can do a Ruby block, and then you can do a code block, and then you can write multi-line code to actually do your conversion. So in order to understand this, you can actually go over here and see Logstash Ruby event API. And what this does is you can understand that the data that is received, that is actually in the form of an event. So Logstash understands it as an event. And you can get particular fields out of this from here, and you can basically run Ruby code on this. And this is like simple Ruby code. If you know Ruby, then you can manipulate the index as you want. So, and once all this is done, this is actually sent to Elasticsearch. So I sent it to only one Elasticsearch, but you can actually put all three nodes over here. And this actually tells you what should be the name of the index. What this does is it automatically creates an index based on the meta information. For example, this will be Filebeat 7.9.1, and this will be today's date. So what this does is that every day, at the end of the day, at 12 o'clock, after 12 o'clock, it creates a new index for the particular day. So for time series database, is actually a very good idea to have rolling indexes which change based on a particular date or an hour, depending on the kind of volume you get. So this is how you use Logstash, and I will just start this. Logstash. Oops. Oops. So let's see if Logstash is running or not. So it actually takes a bit of time. So Filebeat and the other beats, they are pretty fast, but Logstash takes some time. And you should be able to see successfully started Logstash. So this is actually the port for the Logstash API. So this is actually different. So this is not the pipeline that we are using, right? So that's running on a different port. And that should also start over here. I don't know if I can see this. Okay, so Logstash is basically started, and when we get the HA proxy log, Filebeat will send it here. But you can see that the HA proxy log over here. Sorry, not this one. We don't need this anymore. This one. This is actually saying service unavailable because it's expecting a Spring Boot application in the background. So if I go to HA proxy config, it's basically a reverse proxy, and it's a reverse proxy to port 1990 localhost. And what's happening on port 1990 on localhost is that I have a Spring Boot application. Right? So the Spring Boot application is actually a demo, like Spring JPA demo from the Spring Boot application itself. And I just downloaded it, and I just created a jar file out of it, right? And what I also did was that so I can just run this. So I can just do a elastic APM jar. Sorry. So this will start running on port 1990, and what happened over here? So what I will do is before running this, let me also show you installation for Apm, and then we can run the HA proxy, Filebeat, and Apm all together because it's all supposed to come together. So with Apm is also actually installed over here. So again, we use the same process. So we do the sudo apt get install Apm server, I think. So if I go over here, I can check what is the Elastic Apm install. So we can go over here. I don't want to apt. So for this, you can go to the install Apm from repositories, and you can. So it's called Apm Server, right? So you can install Apm Server using the same commands. I think this should work. Yeah. It will be downgraded. Okay, it's probably using another. I think it's already using Apm Server. Yeah, I think when I installed this, 7.9.2 was already out. So this is, yeah, so 7.9. Anyway, this works. So what you do is with you can install Apm like all the others, and Apm Server, and you have Apm Server.yml. So Apm is actually completely different topic, all on its own. So what I've done is I've said that this is the IP address that the Apm server itself needs to listen to. So whenever another Apm agent wants to talk to Apm server, this is the port on which it is listening to. And again, you should see an elastic setting. RAM is not important. And I think it was over here. So you have an output Elasticsearch, and this sends information to Elasticsearch. So we can just service start this using apm server start and password. So we have an APM service running. We can just confirm that. So we have this APM service running, and we can actually send tracing information to this APM server. So the tracing information goes from our jar file, which is this one. This will go to this APM, and then from the APM, it will go into Elasticsearch. So there are different ways of sending information to APM server. You cannot send this information directly to Elasticsearch because APM server actually does some modification to the data. It adds this additional information that turns into a trace. So you need to send it to APM server, and then APM server send it to Elasticsearch. So there are different ways to actually send APM data from the client, from the server to the APM server. So the easiest way that I found is to use an Elastic APM agent. And you can actually find this from, you can do Elastic APM agent. For example, we have a Java application, it's a Java jar. So we can go over here, and I think this is the location, but we need to let me just check. So this is not the one. So yeah, so we can go over here. So you saw with the others that the version number was 7.9 or something. So with APM agent, the versioning numbering is different. So it's 1 point something. So shouldn't be too surprised with this. So finding the agent itself was a bit tricky. Set up the agent, manually set up with this dash Java agent, and then you go to Maven Central. So you use this Java agent option. You go to Maven Central, and then from Maven Central, you can download it over here. Right? So once you download it, so this is the file that I downloaded. This is Elastic APM agent. And to run this, you essentially attach it to your jar file. And how you do that is, actually, I just found this information again on the over here. So it's all given over here. Nothing special about it. But what you do is you pass this agent as a command line argument, right? And what this does is that it instruments the jar file. So it auto instruments some of the jar, parts of the jar file. For example, JDBC calls, REST calls, REST controller calls. These are automatically instrumented, which means that there is a start time before the call and an end time after the call, so that you can tell how much time it took, and that tracing can happen. So what I do is I gave this Java agent dash Java agent Elastic APM agent path over here. Then I did named my app, I call it my demo app. It can be anything. Which package that I want to process is this one. And then I said that this is the APM server. So the APM server is running on the same machine. So I gave it this private IP address, and I told it that where is my Java file that is actually living. So this should run, I hope. Okay, this did not run. Let me see what's going on. Connection to payment failure. So this is running. Let me just try and see, maybe there is an indentation message. No. So it tries to run this service on port 9090. Define then, declare and resolve. So I'm not sure why this happened, but what should happen is that there's a service running on port 9090, and the HF proxy is actually talking back to this. So instead of trying to diagnose this, let me go and show you what the output should be. So I ran this also yesterday, and so Elastic has this full-fledged section called Apm. So you can go over here and you can go to Apm. So previously with Elastic and Kibana, you used to have dashboard for this, but since recently Elastic is maturing a lot, they have these dedicated sections. So Apm has its own section, and so this did show up, but this is not what we're looking for, something else. And so this was actually the request that should have been generated. So oh no, not this one. So there's another one. Let's do a last 48 hours. So this is what happens when you do a live demo. Okay, transactions. So it shows you the transaction that happened in the last 48 hours. And this is not showing up, but but I actually had a really nice transaction over here which showed a database query as well. So I think, yeah, sorry, I was in the wrong one. So my the application that I use, it has this. So it's actually a Spring Boot application, and it has a controller called get, and it has a method called get all users. And when that HA proxy gets called, that calls the Spring Boot application, and this controller gets called. So when you instrument it like this, so this agent over here, it automatically instruments this particular jar file. Right? Actually, let me just check one more thing. Maybe I'm doing the wrong. So what it does is it actually instruments this jar file, and it shows up like this. And if you go over here, it will show you how much time was spent. So there was an app span, and then there's a MySQL database running in the background. So that called a MySQL database. And that was the transaction distribution. So if you have a lot of transactions, so 1 of my transactions, 11 of my transactions took 0 to 50 milliseconds, and one particular request took 600 to 550 milliseconds. And then you can go and actually see that this was actually the trace of the controller, and it called a database query from inside. And this is what the database query itself, right? And how long did this take? And the beauty about this is that you don't need to write any additional line of code to do this open tracing stuff. So this is actually open tracing compliant, and you get all this information out of it. And if you have like a lot of web control, a lot of HTTP controllers, a lot of database queries, they will all start showing up over here, and you can then actually go in and see which of which part of your application has the maximum impact. So if you have a lot of slow queries, they will show up on top, and it will show you that these are having the maximum impact. Like this is the average duration for every query. The 99%, 95% is showing up this much, and these are transactions per minute, and this is the kind of impact it has. So you can do a very nice analysis of the performance of the application. Yeah. So so that's it for me. If anybody has any questions, Ashutosh, if you're still there, you can ask me. I'll try and answer.
Thank you, Sami.
Okay. Okay. Thank you very much, Ashutosh and Michael, for this late night session. I hope everyone took something from it, and and that's it from me. Thank you very much. Bye, everyone.